It sounds kind of like science fiction, but this material architecture is unlike anything anybody has built before. We really think this is a paradigm-shifting change in the nature of materials that are used to create the world.
It's not often that the public gets excited about a building material, but graphene is a special case. The two-dimensional miracle substance promises to transform the way our world is built. That is, if we ever get it out of the lab. To find out how close we are, we visited the team at Graphene Technologies, who recently developed a breakthrough variation that might just make our sci-fi dreams come true.
Hey,
Hi.
you Matt?
Yes.
Hi, I'm Luke. Nice to meet you.
Luke,
You're
pleasure.
Okay? Love to see what you guys do.
Fantastic. So Graphene Technologies is developing a new form of carbon called graphene, and specifically, we're making a foam-like form of graphene. So something that's ultralight, really strong, paradigm-shifting material for
like-
all sorts of applications.
But it's foam.
Yes, it is foam. So what we've essentially done is we've taken traditional foams, which have really big air pockets and really weak walls, and so that's why you use them for packing materials and stuff like that, but not for bridges and skyscrapers. We've taken those and we've made the walls out of the strongest material in the world, graphene, and we've shrunk those bubbles that you would typically find in a foam down by an order of 6 to 9 orders of magnitude.
Wow. Would it be possible for you to show us how strong it is?
Yeah, definitely. Let's go take a look at some of the materials we're making right now.
That'd be brilliant. Thank
Okay.
you.
Luke, I'd like to introduce you to David Brill. David's a materials scientist who is a composites expert and works with these instruments to determine how strong the foams actually are. And so we can demonstrate that for you now.
I'm going to load the sample in, as you can see, and I'm going to turn it on, and it's going to basically just press down on this pellet.
All right, so how many pounds? How many pounds of pressure on this?
About 1,100. That's I mean, think about that, 1,100 pounds on something this small. That's a lot of force.
This is way
Yeah, I mean,
past where it usually goes. And so it's outperforming pretty much everything we've seen up to now.
it's starting to barrel, it's starting to yield a bit, but this is
Serious? What are
after
we at though?
about a ton.
Wow.
So there's a ton
That's
bearing down on
amazing.
this
Yes.
material, which is the same sort of density as bamboo. isn't it?
Yes.
Cellular materials, foam materials, sponges in general are extremely good architectures for absorbing kinetic energy. That's why you use them for packing materials, but typically you don't associate foams with load-bearing applications. So we're trying to get both, right? Our vision ultimately is to transform the human-built environment into anything from skyscrapers, making them taller by using lighter materials, bridges, satellites. We really think this is a paradigm-shifting change in the nature of materials that are used to create the world.
Matt, thank you for showing me what's possible in a world of foam.
Definitely. Thank